now going to go into the, I'm going to say the afternoon session, but the late afternoon session, which is around certainty. And first up, we've got Jason, who you met at the beginning, and he's going to talk to us about hand and vision, tools for configuring creative engagement.
Thank you. Okay, so the tools for consideration here are structures situated in museums and art galleries that afford interactions and engagement between visitors and collections, and so should more properly be called hand and vision and other people. And I guess that kind of relates to what Liz was talking about before. The design of my own installations have been iteratively developed over a number of years and take into account James Gibson's canonical understanding of affordances. These physical structures that give clues to use and function, the tacit understandings of how things may be used. And as I say, in addition, my practice takes into account the aesthetic and the social within the museum's ecology of action. The public understanding of science has always been an area at the forefront of interactive exhibit design. This exhibit here was part of the Science Museum in London's Children's Gallery. Formed in 1931, the then Science Museum director, Sir Henry Lyons, argued that in the technical museum, the needs of the ordinary visitor should be placed ahead of those of specialists. Clearly, some early attempts proved to be somewhat intelligible. We can see these glum faces of the children here. This is more like it. So here we see some kinesthetic learning. These children will perhaps not only have understood the principles at play, but will have, by virtue of the exhibit's designed affordances, become part of a crane, and through their own agency, and importantly, have done so in the company of others. As a child, I often went to the Science Museum myself, and a distinct memory of these visits was a large round table, in the middle of which nestled a golden ball. If you tried to reach for it, it dropped away. This was demonstrating some kind of motion sensing technology. This seemed extraordinary to me at the time, not only for the marvel of the technology, but the excitement engendered in the children gathered around. I continued to be interested in exhibit design, not only as a designer, but as a punter too. However, many exhibits rely on what James Bradbourne describes as linear design. You pull the rope, you press the button, something happens. Whilst these are briefly successful, often they fail at holding continued active engagement. Visitors need creative agency to bring their own interests and preoccupations, to increase the complexity of actions, thereby increasing meaning and memory making during their visits. What can more open-ended visits offer? One possibility is playfulness. Here's me confirming my choice of words with a relatively open-ended exhibit. Open-endedness brings with it not only more personal engagement, but also increased risk. If you grant agency and creative freedom, how do the design affordances support learning? This is the universal curator. I built it to support engagement with museum objects in a playful way. It asked the visitor to arrange and curate simple copies of key museum artifacts. It had handles, and more handles, and screens and a camera, and objects to be arranged so that they would appear in a personalized cabinet of curiosities on the wall. But what did visitors do when they're given choices? The answer is they take advantage. And fueled by intrinsic motivation, they exhibit epistemic and ludic behavior. They look for opportunities. In this case, putting their faces very close to the camera. This is an artist's impression of what those particular visitors were after. Despite my own hopes for interpretive success, They wanted to perform and engage in a different way. So how about certainty? Well, there's no sure thing, but there are some ways of deploying reasonably reliable affordances. One possibility is to help create engaging opportunities through activities like drawing. Drawing is a fantastic way of engaging with museum objects, but people are often self-conscious, so they need supporting structures. With this piece, I appropriated Dura's grid system and built a mobile drawing machine to help visitors draw museum artifacts. This piece, called the Interactive Work Table and Escritoire, was another attempt to allow participants to creatively engage and for their responses to be preserved and reviewed online. The context here being Dr. Johnson's actual garret room, where he compiled his well-known pictures. This piece had some instructions, but it was also intuitive. An obvious set of affordances: a desk, a pen, a book, and the clear historical situation. So the open-endedness allows for the creative agency, while the visitor is happy to play along with the narrative affordances within my design. My own approach to designing for museums is often driven by a heuristic urge to make sculptural forms that support a range of actions in a number of users. A concern while considering the design of these interactive tools is that testing is hard to achieve within specific contexts. That's to say, planning cannot happen during the time that you are making for. So you do have to build on previous experiences and test on small scales where possible with real people. Another useful thing is seeing what else is out there and observing the designs of others in the wild. The rather nice piece here that looks at a slice of granite under light in a visitor centre. And here ideas might be reinforced or assumptions challenged about what works. This is a fantastic piece looking at Constable's sketch drawings, an interactive piece. So this piece here, The Enlightened Eye, is a complex piece that builds on some of those lessons learned. Handles move things. They allow visitors agency of objects. Here's a prototype developed for testing, consisting of a microscope supported over a rotating array of specimens. You can see a shell here and a fly and some broken ceramics. And through small sensitive physical movements of the handle, the affordance feedback is amplified on the screen, and people really enjoy doing that. They really enjoy seeing their actions amplified. The engagement is clear. So as we've seen, drawing in museums is a great way to engage. People really become immersed and create a connection with objects in collections. You often see this if you visit museums and art galleries. You do see specially provided spaces and stools that people can sit on to draw and so on, looking closely at objects, taking something of that object into their own mind. So with this design, I harnessed a common instinct to find shapes in close-up images of museum mineral samples. These comparative morphologies allow creativity and agency over objects and provide structure for the task. In a sense, it's another version of Dura's drawing grid. Try saying that. Also, what I want is to, and wanted with this piece particularly, is to encourage a sense of gathering around, a closeness of shared active attention. And I often came across examples when visiting museums and so on, where these things happen. You have these lovely moments of attentiveness. sort of people joining together in a task. Another thing I considered was the compositional, functional and aesthetic affordances that you find in things, particularly mechanical qualities of machines. And they're really useful to appropriate and incorporate in the design. Clearly, handles are one of those, but also forms that have a kind of directionality, a visual dynamic. This also relies on the tacit understanding of how devices are worked and used that people often, of course, know about from previous experience. So in this piece, we have a controlling action and a manipulation of real, authentic museum objects, but still allowing for the preservation of those objects. So these were objects that belong to a museum. They're acquisitions that need to be handled sensitively. But what I wanted here was to allow people to be able to move them. And also, you know, an audience to share the results with. And a touch screen, as well as a focusing wheel, combined together to form intelligible digital and analog affordances. So the visitor selects a sample, maneuvering it close to the microscope using the handle that drives the planetary gears that moves the rock in front of the microscope. And then you wind the handle to select a spot. And draw over the top with your finger on the touch screen to reveal forms, identify structures. Here's the piece in its context, a minerals and mining exhibit in a small Cornish museum. And within this space, there were other objects to do with mining and mineralogy and some other interactive interfaces in the same space. So here's the screen that allows you to make your choices. Once you've selected your bit of mineral, you can then draw over the top. Here's an example. And the affordance is relatively obvious. I spent a lot of time working with a research technologist to develop this, which perhaps looks quite simple, but we did spend a lot of time working out this particular interface so that you were able to put your own drawings onto the surface or trace structures. Another agency for this tool or this machine was you were able to send your images up onto the web and review them and look at them later and see what other people have done as well. And there was an awful lot of these during the time that the machine was active. And there's lots of creative agency, sometimes surprising, sometimes beautiful, and a kind of assertion of presence, you know, like I was here is the classic. However, I consider the most important aspect of these projects is how it attempts not only to support individual engagement, but how it is often critical that these creative actions and engagements are created and revealed through the social. Common goals are shared and discussed. There are many instances of visitors working together, which is one of the intentions of the machine, to have multiple multimodal affordances, so that more than one person operating it was actually a good thing. Oh, this is a face that the young girl drew from the previous slide. Family groups fall into prolonged active engagement. Here's an adult. The male takes control. Everybody has to wait until he understands and shares his knowledge. He signals his internal creative considerations, making a small diagram in the air, a metaphoric gesture of his plans. The youngest in this group also pantomimes his internal preparatory thoughts through an even more complicated design to make his moonlit dinosaur. A group of children dart around the ecology of action, not really following my rules, but still engaged and active and looking for control, to have a go, to be part of the action. Epistemic flow states are accommodated by those who understand their group, revealing sensitivities towards each other's motivations. This is the result of a lot of hard work. The boy in the previous slide carefully landing the TARDIS on a lump of crystal, a shared and individual endeavour. To finish, here's a rather splendid king and this scary monster that appeared one day. These were the kinds of results that I'd hoped for, individual, shared and channeled by the tool, the device and its designed affordances. The implication of this work shows how close examination through data capture and data analysis can help to influence design decisions for this rather and often unpredictable design challenge. Thank you.
Hello, everybody. Thank you very much for inviting me to talk about my work. That was a fascinating talk from Christian, and there are some things in my talk which I think connect in with that, especially the idea of embodied knowledge. So I'm going to talk about, I'm a ceramic designer, maker, researcher, and more recently a curator for the White Gold Project in St Austell, an arts and regeneration project in clay country where china clay has been traditionally mined in the UK. But to start with, I'm going to talk about a couple of machines that I made when I was Associate Professor of Design at Falmouth University, working with Jason and with Justin Marshall, who I notice is in the audience. And to explore those things and some of my frustrations with those working on developing those tools. And then I'm going to talk about a project that I've been curating over the last 2 years, which is called Brickfield, which is an experimental brickworks based in clay country in a disused china clay pit, which is actually led by an artist called Rosanna Martin. I don't seem to be able to move my, there we go, okay. So just to give you a bit of a flavour of what I was working on when I was at Falmouth, I'm very interested in drawing and creating surface pattern and combining digital and physical tools together to make surface pattern design. So these designs are based on a traditional British chinoiserie pattern from the 18th century and developed through photography software and plotting, specifically plotting software that's used by architects, which is no longer available, to generate this particular sort of pattern. And these are laid on with a digital transfer process. I just need to click. And this similarly is a design based on a chinoiserie, but also drawing on my family life, domestic life, images of boys on the sofa, which you'll see in the next slide, but also using the same plotting software to create the digital imagery that I'm planning to transfer onto a pot. In this case, using an Enoto pen, which is a pen that you draw on special paper, which actually Jason used in his Dr. Johnson's project. The paper has lots and lots of tiny dots on it, and it records the movement of the pen across the dots, records your drawing. So I was using that to draw from life and using photography, and then translating those designs using Adobe Illustrator, and then to create CNC programming data for a milling machine, and translating that into low relief for making ceramic vase, this is actually quite a large scale piece. Very, very complex processes involved in getting from my hand drawing, very direct manual process, to this quite sophisticated surface, but actually feeling very distanced from the object in the creation of that. We, as a group, decided that we'd like to try and make a drawing machine that would perhaps enable us to have a bit more control ourselves and interact more directly. Sorry, my slides seem to be jumping forward. I don't know why that's happening. To interact a bit more directly ourselves with the process of drawing. So we worked together with Dave Turtle, who's a technologist at the Royal College of Art, and with technologists at Falmouth University to make our own drawing machine, and that's Jason there helping with that. And you can see that it was quite a team effort. There's quite a lot of people involved in this process. It's very definitely collaborative. And my role really was in trying to developing drawings, and then in creating a machine head for the drawing machine that would take slip. And so I could slip trail directly onto a plaster slab. So trying to make a machine that used the physical material that I've always loved, that I'm passionate about, that I want to get my hands on, actually. And I still feel quite ambivalent about these machines and their inability to have the subtlety that Christian was talking about in relation to the way that hand movements go on. But we had a lot of fun making machines do things, and I managed to kind of start doing some drawing with it. And actually I got quite physical with this machine. I had to interact with it quite a lot because there are a lot of things going on in terms of viscosity of the clay running through the nozzle, and the speed at which you move the machine head to create a line. So actually I had to be very present with that machine to achieve some results. And there was a huge amount of uncertainty and risk, and a huge amount of failure and disappointment, which, you know, there is quite often with ceramics anyway. It's fraught with risk. It's the nature of the material and the firing process and so on. The image at the bottom there is, I'm still looking at chinoiserie. I'm still looking at traditional patterns to generate my surfaces. And these are the pots that I ended up with at the end of that process. I then went on to develop a machine that we called the BrushBot. Again, trying to make a stronger connection between myself, the drawing, and a physical output. And with this machine, you drew on the Wacom tablets, and what you were drawing appeared on the screen in front of you that you can see there on the laptop. But what you were actually painting was going on this mini painting machine on the left, which had a series of coloured pots and a series of brushes that you could pick up. And so you could make a series of different sorts of mark, and you could choose which brush you wanted to use, and you could choose which colour you wanted to use. And you could record what you did with the idea that then the machine would reproduce what you'd done. And I had kind of imagined that this might work quite nicely with ceramic tile designs, that you could capture a master painting and that you could put a tile in there and reproduce that using the machine. And so what you see there is the drawing that's created in the software by me drawing on the Wacom, and then the painting that's been done by the machine next to the drawing. So we had to do quite a lot of work on this, designing the interface for it and making the machine do the things that we wanted it to do. It was quite strange working on the Wacom, looking at the screen and looking across at what the actual machine was doing. And that's the machine there. Unfortunately, I don't have any video of it working to show you. And there you can see my master on the left, my original painting, and then what the machine did on the right. And obviously it had a bit of a glitch and didn't quite finish the spiky bits on the cactus that I drew. However, there's other artists who've had a go, and this is, you know, master on the left and copy on the right. So it's pretty true to what you can do. So I left academia in 2016, and also kind of left behind some of that digital interaction that I've been involved in. And I still, you know, I have an interest in it, but there's a very, very strong part of me that wanted to get closer to the material again, get closer to clay and get my hands on it. I think kind of in relation to some of the frustration of having to work in a way that was indirect through the screen, through the technology, always trying to bring those things together, the humanity of making and the digital technology together, but actually finding that very difficult to achieve. So I've been working on Brickfield. It's an experimental brickworks based in Clay Country, but it started, and its objective is to reintroduce people to the land, to material, and the material that's beneath their feet, and to give them agency with that material, to get them to see that they can make things with that. And this is a scene on the River Fowl, which has a huge amount of washout from St Austell Clay Country clay. You can literally dig the clay out of the riverbed and use it. You can't really use it completely raw. So anyway, you get a bit of contrast here between the kind of technology that I was working with before, and now we've got big buckets of grimy, sloppy, slurpy mud. And a bit of straw there to add in. And we're working with really, really primary tools. It's a wooden block, and we are making the clay on the site and pressing it into the molds and making bricks. And this is the really, really rudimentary kiln that we made in our first iteration of Brickfield, which is based on a traditional clamp kiln. It didn't really work, but it was great fun to make. We had a lot of very wet bricks, but we learned some of the principles of very basic brick making, and we brought people together to discuss the land, the heritage of brick making on this particular site that had been a brickworks, which had emerged because of the washout of clay from Clay Country on that part of the Fowl. And people gathered round the fire to tell stories and talk about the land. And there's some of the bricks that we made. So I think it's interesting here that the bricks are the tool, are a tool, going back to the architecture talk earlier in terms of architecture being a tool. I think while we are making bricks, the bricks themselves are a tool. And then we got an idea about what traditional brickworks might look like, or did look like, and digging out the clay from the land and listing up the tools. This 18th century or possibly 19th century diagram of a French briqueterie with all the tools labelled. It's a beautiful book of etchings, and we got a real sense of, oh my God, look at the size of that kiln. Those people are actually walking on top of it, and that's all solid bricks with tunnels going in for lighting the fires. So that kind of really whet our appetite, and we started to look for a site, and we did that by looking at the working with Imris, who are the French company who own large proportions of the clay country around St Austell, and a larger, increasing proportion of which is disused. And a lot of people feel very disenfranchised from that landscape. A lot of local people used to work there. It was their livelihood, and it is no longer. And there is quite a lot of reparation to be done in terms of reintroducing that land, or rethinking that land, reimagining it as a place where we might do things as a community. So I love this picture, which makes all the machines look like tiny little toys in a sandpit, which is, of course, it's absolutely massive. And we were very kindly given this site by Imris to set up our very primary experimental brickworks. You can see there's absolutely nothing there. It's an old gravel pit. And there we were, kind of just us in the landscape. What do we do? How do we make this thing? So we got a container, we set up a very rudimentary shelter. We had several tons of clay delivered from Imris. This was last year. This year we have had tons of clay delivered that have literally been dug up from another site in Clay Country. It's clay, it's in the land, it moves around, the clay moves around the landscape all the time in Clay Country. There are no Ordnance Survey, I can't think of the word, levels. You can't see the heights of the land in Clay Country because it shifts around all the time. So we set up this rudimentary brickworks. We invited people to come and walk with us on the land, and we invited them to come and make bricks with us. And in that process, we met a man who was a brickmaker and fired the last kiln in Kiln Country, the last brickmaking kiln, in 1971, and he's called John Osborne. And he started to teach us how to do brickmaking properly. And he showed us the old brickworks where he used to work, which he hadn't visited for 50 years. He took us back there. We're inside the kiln on the right, and that's the entrance to one of the old kilns on the left. And John got us this huge amount of clay, which you can see there, from Brickwork Hill, which just arrived on a massive truck, and dumped it on our experimental brickwork space. And we were faced with, well, how the bloody hell do we interact with this material? So John just lashed up this massive sieve, which I absolutely loved. I arrived on site and I just thought, this is an amazing thing. And here we are, just chucking the clay through the sieve. And then we have various grades of sieve to make our material, and mixing Brickwork Hill, which is a ball clay, with the china clay that you can see in the front there. And then mixing it in a huge tub, and doing that by hand with big sticks, and quite a lot with our feet, which was very pleasurable. But extremely hard work, to go back to Gareth's, some of Gareth's references. It's this, a lot of the time when you're doing this, it's fun to start with, and then you're going, oh my God, there must be more efficient ways of doing this. And I think we had to remind ourselves quite a lot of the time that what we were doing was trying to, that was part of our learning process, to engage with the land and engage with the materials. So am I running out of time?
You round up a bit. Sorry to loom in the
Round up,
background.
okay. So John, basically, I just want to show you a video of John, maybe. Have I actually run out of time? Because I didn't see a message.
No, it's fine. If you want to share this, and then we can catch up, that's fine.
Okay. So just to talk about John's embodied knowledge and him kind of being a tool himself, to show him doing a demo.
Could go wrong.
Sorry, it's a bit quiet. Oh. Sorry. Okay, so just to show you that his body movements there are really interesting, I think, in terms of his embodied knowledge of how to make the brick. And then we had community, and we made as many bricks as we could in a day. 370 bricks in a day is all we managed. John used to make 700 bricks in a day. And here we are moving the bricks around. And then we designed a kiln based on a beehive kiln, and we built that using bricks that we'd reclaimed from John's old brickwork. So again, we're busy making the tool, huge amounts of work, scrubbing bricks to make the kiln, and then huge amounts of work, firing it, chopping wood, feeding the furnaces, which we did 48 hours of chopping to fuel this kiln to get it fired up to temperature. So it was like us against the kiln to try and reach temperature. And that's what the chimney looked like in the end. And we ended up with 500 beautiful red bricks from our kiln. And so next year, we're hoping to run the project again, and we're thinking about what tool we can make for next year that will still have that character of a manual, have a manual element to it, but will kind of improve some of our capabilities. And we're thinking that that will be a manual, what's called an edge runner mill, which will be a clay mixing machine, but it will still have this manual element. And really, I think that the project is very much about retaining that manual labour and thinking about that, what we're doing by being manual. Okay, thank you.
Amazing, thank you very much, Casey. It's amazing to see the circularity of that as well. Okay, next up we've got TASLIM Martin, who's going to be talking to us about appropriate use with regards to digital tools he's used in public art sculpture, which he's been doing. Okay, thank you very much.
Tremendous. Okay. Well, first of all, thank you very much for inviting me to contribute. Appropriate use. My background's actually in carpentry and joinery. I did that 13 years before I went to art school as a mature student. And so I'm sort of familiar with a range of tools. But what I have done subsequently, having graduated, is a bit sort of varied. There's a range of stuff. Craft skills are very important in what I do, and the image that you can see here is actually a bench made out of terrazzo employs, and all of the projects which I'm going to be showing employs to some greater or lesser degree digital element. There's extruded elements in this and revolved elements, which are all principles which work very well in 3D design packages. This is the first public art commission that I was awarded for a town centre in Bracknell, and it required two bench designs, a total of 10 benches. What you can see here is the back of a high-backed terrazzo English oak and stainless steel, and in the background in the trees you can see a sculptural centerpiece in the form of a large terrazzo egg sculpture. This is the other design, which is a low wide seat which allows sitting from either side. This is another project for Cambridge, and please forgive the rather cheesy publicity shot. That's a maquette which taught me quite a lot. It also helped me win the commission because steering groups famously don't really know what they want, and they like to have physical objects in front of them because that, you know, their eyes light up and they can handle it and move it around. This also taught me a lot about how I would go about making the actual real thing, namely that I mean, this is quite simple shape. But it relies rather heavily on one module, 20 arcs with a prescribed bird's mouth mitre on each end, and it needs to go together really rather accurately. And so because of that small maquette, I realized that in the larger fabrication of the real thing, very accurate jig needed to be made, and that's what you can see here in the bottom right hand corner, and that's what it looked like in the end. It's a 10-foot diameter open space frame sphere. Okay, this next project is following on from Katie's brick experience. This is for Milton Keynes. It's a public art sculpture, rudimentary drawings of how it would sit in the landscape, which were made by me on this occasion. And I'll just push it on. It's a simple idea. It's a Roman utilitarian vessels, alluding to the fact that Milton Keynes is built on, you know, sort of old Roman remains. In fact, about 2.5 miles away from the actual site, there was a villa, a beautiful villa, which obviously belonged to someone quite important in the Roman Empire. And yeah, okay, this is the making process, lots of jigs and patterns, which allowed a degree of precision which was required for the forming of the sculpture. And here you can see the fired bricks at the factory and laid out on a template in the top there, in the bottom in a cradle, put together with mortar, and on the right hand side you see a concrete core around which all the brickwork was laid. and that's what it looked like complete. Yeah, there was 2 of them, and they're quite heavy. It's complete guesswork on this in terms of how heavy they were going to be, but given that they were supposed to be anchored in the landscape, that wasn't the problem. However, normally when you make brick walls, they're not required to be transported 60 miles on the motorway on the back of a lorry. So that was quite a nerve-wracking experience. Yeah, I think I'll move on swiftly. Okay, this next project was a much smaller piece, but employed a lot of jig and pattern making and running molds from the fibrous plaster industry. In ceramics, we'd call it sledging. And what you can see me holding in that bottom left-hand corner is sledge. So essentially that's just a big arm with a template which prescribes the shape of the plaster which is going to be run to follow that path. Yeah, I'll move on. Yeah, so this is what the thing looked like in the end. It's basically 2 elements. I did all the pattern and mold making. Now, I'm self-taught when it comes to that sort of thing, and it's a bit of a dark art. No one will tell you anything really, but it seemed to work, and I took it to a foundry, and they seemed sufficiently curious enough to actually cast it for me. They cast a couple of them for me for nothing, simply because they were, you know, really interested to see whether it would work. So the base elements are out of the same mold, they are identical. The top saddle part dovetails into the base elements, and what you can see in the foreground here is a butterfly extrusion which slides up the center and locks the whole thing together. And that's what it looked like. It's called Secret Dovetail because the dovetail of the title is the one that you don't see. This is another project which I got involved with. It was kind of the centerpiece for a show I had up in Doncaster. No, it wasn't Doncaster, was it? Oh, Rochdale, sorry. This is another sledge or running mold, this time a little bit more complicated, not a straight extrusion or indeed a revolved one. It follows a helix shape, a bit like a handrail when you're going down a spiral or up a spiral staircase. And so that sort of U shape follows this path, a prescribed path, which with a bit of judicious mold making, you're able to repeat this module and then join it together. And in so doing, it produces this arc. It's about two meters long, and it's about a centimeter thick, and it's this hollow plaster shell. Right. Nothing quite like adrenaline. I'm rattling through these images. This next one was a project which I did for Brixton, and a little bit more recently on the less simple CAD drawings. It's easy to come up with an idea, and I employed a friend to do the CG visuals, which probably got me the job in the first place. Then you're charged with actually realizing the thing. Now, this was well beyond my ken in terms of the actual CNC engineering for the pattern making. So I handed that over to someone else, and they did a magnificent job. I have flirted with computer drafting, and I know enough about it to know that it would serve me very well to be much better at it. More of that later. So this is what I got back just before the pattern coat. So they'd come to my studio, and then I'd have to clean them up and then apply pattern coat, stick them into a box, and this is in the foundry. So essentially it's a bit where you're making 2 of these patterns for each shape. The actual sculpture was made up of 8 different individual shaped cast elements, curved panels. Now, that meant 16 of these patterns. So you need 2 of these patterns for each panel which you're casting. And this is what it looked like put together with bolted and welded from the inside. Now, it said that even though you know how to do a job, you don't really know how to do it until you've done it. And then when you've done it, you realize how you should have done it. And this is very much the case with this project. I would never do it the same again. This is what it looks like in place. Quite large, about 3/4 of a ton each. One is, they're identical apart from different metal, so they're from the same mold, or set of molds, should I say. The one is ductile cast iron, and the other is marine grade stainless steel. Okay, this is a project which I did for the Horniman Museum in 2007, and it was to commemorate the bicentenary of the abolition of the transatlantic slave trade. Now, the Horniman's a wonderful museum, award-winning, really very child-friendly, just, you know, lovely, lovely stuff. And it's quite a heavy, weighty issue, and I was unsure as to what to do, and I resolved on making a globe with details of the path that the transatlantic slave trade took, and what different cargoes were picked up in different locations, and obviously that includes the enslaved Africans. Now, there was quite a lot of engineering involved in the making of this globe. It sits in this circular table and it rotates, but the really tricky bit for this project was certainly getting the map of the globe onto a spherical object. I don't have time to go into it right here and now, but believe me, I employed my brother on this one, and he has a degree in maths and computing, and he really struggled. Okay, this is more into what I've been doing during lockdown and engaging with a 3D package, specifically Rhino. This is the first design I really struggled to try and make, and the idea was to make something quite large, a bit like a centerpiece or a fruit tray, something like that. And this is when I got to play with a CNC router and using the Z-axis with some end grain hardwood. Same idea, same file, 2 different scales, one very small in porcelain, a pendant, jewelry, and the other a larger, more architectural, wavy, textured panel. What I think is perhaps the real strength of the digital is the ability it gives you to work through many iterations. And in so doing, if you're going to engage in a piece of work which is really quite time consuming, and much of the work which I've shown is exactly that, then it helps to have some sort of confidence that you know what it's going to look like, and you've gone through a few different options and you've resolved that this is probably the best option. And so, whilst this is all, none of this is particularly digital, I did do some drawings and I played around with different combinations before I got to this. This is kind of what I cut my teeth on during the lockdown. I designed a range of door furniture, handles and knobs, employing once again that bobbly texture that you saw earlier. Just having a bit of fun, and more importantly, perhaps learning how to use the program. Okay. Jewelry, yes. I imagined I knew something about 3D printing and PLA and chiefly that I didn't really like it as a material. I thought it was quite nasty, but I didn't realize that you could actually finish it quite well. And that's what you see here. This is all PLA. And, you know, whilst the rings are, you know, quite simple entry level signet rings, the finish in those pop colors, you know, all of a sudden gives it possibilities. On the left is a form study, which I'd quite like to see in different materials and perhaps at a different scale. Okay, this is the last image, and this is hot off the press, as it were. This is a task lamp, which all of the elements that you see, which aren't wood, are 3D printed in PLA and finished. The rather conventional head with the ball and socket joint is pretty straightforward, but the main body articulation that you see is something which I worked on, and it has a pipe which goes through the center that holds the main you know, oak stay to the upright oak, and that's held because it's barrel shaped, and it has well, the technical term is a split bush bearing, but it's of my own devising, and it's, yeah, I mean, it kind of works. And also it has this embodied friction which allows you to manipulate and you know, the articulated arm, and it stays in position. So you're actually using the materials property to create this hinge with this big hole in the center, which is the real feature of this design. I'm still working on it as a prototype, but I'm having a bit of fun with it. Appropriate use, I would say that we've all used screwdrivers as chisels, and I think I'm quite keen on the idea of quick and dirty. You know, you take what you need from any particular process to get the result that you require. And yeah, thank you very much.
Fantastic, thanks Taz. I love the right on time, just as your alarm went off there. Time to perfection. Talking of certainty. Brilliant, that was really good. It raised quite a few questions I want to bring up when we get to our discussion as well. But moving on, I'm going to introduce now Bridget Harvey, and she's going to talk to us about jigs. I'll let her explain what that means.
Great. Yeah, my name's Bridget Harvey. I'm a maker, and my work's really concerned with the nature of craft and making. So what we make, how we make it, and really why that matters. Through my practice, I examine society, materiality, and making, and I use the underlying concepts of processes, materials used, and objects produced to discuss the kind of unseen purposes of making in a way with which we can deepen our relationship with our hand skills and our possessions. As well as making objects, I run workshops, I speak and write about my work, and I teach. And while I do personally work with specialist tools and materials, I'm also really interested in lo-fi or relatively inclusive ways of working, social engagement and responsibilities. I also believe that as well as skilled material knowledge, making can show political intent. And by acknowledging the complexities of craft across time, class, place, and intention, we can discuss what making actually means today. And then for the past sort of 7 or so years, I've focused on repair as embedded in craft and as independent practice of its own. But today I'm going to talk about jigs. So first I'm going to talk about them as devices for guiding us, and then I'm going to talk about repair thinking, a jig I'm proposing as a way to help design repair back into our objects and our practices. So firstly, what is a jig? According to the Oxford English Dictionary, a jig is a device that holds a piece of work and guides the tool operating on it. Wood Turner and theorist David Pye suggests that all workmen using the workmanship of risk are constantly devising ways to limit the risk by using such things as jigs and templates. If you want to draw a straight line with your pen, you do not go at it freehand, but use a ruler, that is to say, a jig. He tells us that the use of jigs is ancient, but while they can mitigate risk, the risk of spoiling your handwork is always real. Jigs can only help achieve regulation in making. Similarly, philosopher and motorbike mechanic Matthew Crawford describes them or calls them a device or procedure that guides a repeated action by constraining the environment in such a way as to make the action go smoothly, the same each time, without his having to think about it. So a jig is a material tool or an extension of a tool. It aids repetition, accuracy, and workmanship, but they're also more than this. Both Crawford and sociologist Richard Sennett discuss the deliberate setup of workspaces, tools, and materials to enable navigation with minimal thought. Crawford suggests that this reduces freedom but stabilizes things, and as such lightens the burden on memory and physical processes. And drawing on others' research, he suggests that to do this is to jig one's space informationally, calling it a physical jig, and allowing for what Sennett then calls the informal gestures of work. Crawford goes on to name as cultural jigs, those which we offload further mental burden onto for external organisations, so tools which help position us in a networked society and extend our own capabilities by doing so. So in this sense, jigs could also be seen as devices for learning and agency. Writer Peter Dormer expands on that, telling us that schematic structures, recipes, and jigs are methods for successful making and learning, using mimicry, contextualized external standards, and engaging with demonstrations to bridge the gulf between the student's incomprehension and the teacher's knowledge. Jigs are, as Pai puts it, shape determining. And Peter Dormer again acknowledges that jigs could limit the learner by becoming the only way to do something, but counters this by suggesting that the individual decides if he or she wishes to make do or go further. Crawford again echoes this by recognising the rigidity of the jig, but suggesting that it's deployed flexibly in the intelligent ordering of the environment by someone who is in command of his own actions. So as makers, we think of jigs as material holding and guiding our work and creating certainty, allowing for repetition and helping us to make things really exactingly. But jigs, though, are also informational, relieving us of some mental burden, and cultural, extending that relief outwards. The workman is, as Pai tells us, the agency which provides the tools, jigs, prototypes, and other material basis for mass production. He goes on to say that those jigs are the stored embodiment of the care and judgment and dexterity exercised by the workman at an earlier time. Crawford tells us that for humans, tools point to the necessity of moral inquiry, taking them from ambiguous to usable objects and making concrete our potential for affect on the world. So jigs as useful methods of condensing information can also be used as discussion points, taking them from ambiguous to usual. But what of repair work where each break needs addressing individually? It's the workman's agency and care that addresses the broken object when it asks for our attention. I think that we should locate repair in not least design and making practices, as well as being a responsive action to a break. That is to say, repair is something that may occur in the future and needs addressing now, as well as a response to the past. And I'm proposing repair thinking as a jig in order to outsource some of the issues of repair making back in time, meaning that current focus can be on the individualistic aims of repair making, which also eliminates some work once repair thinking is established in your practice. Now, Crawford would see repair thinking as a structure laid out by someone else and call it a background jig. But this for me is a little bit passive, and so I'm going to paraphrase Ivan Illich in saying that information makes you a worker, not simply an operator. And repair thinking embeds the information needed to be a repair maker and build a pattern of responses and habits for this. So repair thinking is then a device for aiding attention to repair and potentially a decisional jig. So I'm going to run through the idea of repair thinking really quickly now. So Considering visibility is to think about how we might increase the sharing of repair making, be that via visible men's, slogan t-shirts, shop signs, labels, or use of hashtags to increase the knowledge of repair and repair services, and also to show repairability. Canny use of visibility increases the possibility for more objects to be both repairable and repaired, and for more people to engage with repair making. Openness concerns us with the material, but also the intellectual, suggesting we make easily accessible objects and repair information, along with an openness to the potential for innovation through repair, sharing and design, and user feedback. Repair thinking suggests that a deliberate activist openness encourages a multi-way conversation and reciprocal relationships. The ability to fix things or have them fixed is integral to ownership, but barriers to this are frequently designed in. Consciously constructing our objects, which are unmakeable, means that later deconstruction is facilitated through accessible objects and maybe universal or replaceable parts and fixings, and it also thinking about eliminating the practice of black boxing. But I also think that to propose repair as a genuine environmental action, we must expand beyond the idea of the human user to being non-anthropocentric, understanding the user to be part of an ecosystem where the needs of the environment are as important as those of the people. And information about how objects are used, cared for, and disposed of can inform new cycles for repair while embedding it in, say, the circular economy. Lastly, social values requires us to contemplate and manifest the realignment of ownership and power achieved by repair making. So this comes from a resistant and disobedient craft practice. Choosing to repair or attempt to repair something diverts it from landfill or recycling processes and lessens the need to buy new, and this is a powerful choice. Micro challenges and action individuals and small groups feed into the larger resistance needed to create macro changes. So, to sum up, Richard Sennett again tells us that repair is a fundamental category of craftsmanship. Today, again, an expert is seen as someone who can equally make and repair. And he also tells us that acts of repair are a proving ground for all tools. And Matthew Crawford tells us that the jig as it is used in a skilled practice is located somewhere between the overdetermination of the assembly line and the ideal of autonomy. While fundamental in craft, repair bucks what we know of making by being always bespoke but high or low skill, by being irregular but patterned. To be a practicable craft skill, we need to plan for it in advance. So today I've discussed jigs as material guide and certainty as devices for lightening mental burden, for agency and learning, and for care and mass production. But for an act such as repair making, the overdetermination of material jigs are not generally practical. Many cultural jigs have been designed out, and background jigs seem to take away the agency of the maker. My hope for repair thinking as material guidance and instructional aid to material practice is that it can instigate autonomous engagement with repair during the design and making processes, as well as after breakage. I've suggested repair thinking as a decisional jig for addressing repair as a fundamental, as something that can be designed in to reduce waste, increase autonomy, and address some of the politics of ownership, and most importantly, really, enable material and practiced repair. And that's that.
Fantastic. Thank you very much, Bridget. That's really fascinating. So now, if you want to stay on, Bridget, and all the other panelists from Certainty, if you can put your videos and microphones on, and we'll talk through chats. As we said before, I think we're going to combine. Thanks to everybody for sticking to your timing so well, but I think we'll combine the Q&A questions that the audience have sent in with general questions as well. And I can see a few panelists have been answering as we've gone along with some very fascinating discussions going on there. But I think I'll start off just by, we've probably answered this question already with the connection issues and being in lockdown for a start, but is certainty an impossibility? I don't know if you want to pick that up, Jason. You seem to quite like that one.
Yes, probably. I mean,
should we move on?
So yeah, I mean, working with people as I am, kind of trying to direct them towards doing certain things, that they always do something else as well. I mean, mostly I have learned from things in the past, and therefore I can apply those iterations. But I guess and it's coming up here, and I was trying to answer a question to Marsha Bradfield about how people try to hold on to any small success that they have with a design, and then that sort of overwhelms any way of moving forward, and you must learn to learn from your mistakes. It's critical. So actually failure is, as you know, it's pretty obvious, I suppose, is really important. Yeah,
it's interesting you mentioned Marsha Bradfield's question there, because I saw, Bridget, you've been talking to her before your session, and you're talking about, getting it wrong is kind of part of the process, and students quite often can be put off by that, and thinking there is a certainty and you need to get it exactly right. And I saw you were sort of discussing further about that, about how do you almost teach design process to people and get them to accept that.
I personally like try and use sort of material examples for that. So there's sort of, I think, acceptance of that you're not going to learn how to use a tool straight away, or you're not going to be able to do something perfectly straight away. I use examples such as the light bulb or post-it notes, that are sort of highly successful common objects now, but actually took a lot of working at, a lot of practice, a lot of learning how to use different things in different ways, and to also think about outcomes in different ways, which is sometimes successful and sometimes not.
Yeah, that reminds me, actually, when we did a bibliography, I happen to have it here, there's this amazing book, Sweatsu Yanagi, and then Craftsman, and he talks about the idea of the perfect design. Basically, you can very rarely find the maker of, if you think of something which is perfectly made, like a baseball bat, or if you use as a teapot or a bowl, it's generations of people perfecting quite a common shape or objects until you basically end up with something which fulfills its purpose exactly. And I kind of wonder if there's particularly when we were talking before, and Katie, you were talking about sort of the problems of applying digital to handmade processes. Maybe that's somewhere where digital can help, because you can speed up that process rather than waiting a generation. You can actually kind of, almost fast forward. Or not.
I mean, they're only really perfect at one point in time, right? Because the object has to adapt to the people using it, and then the tools have to be adapted to how the people using it want it then to be. So that those things are always iterating, and the tools to make them are always iterating too, in a lot of ways, I think.
Yeah.
But ergonomics don't change, do they? We're still
but physical size does. Like, we are larger than our predecessors generally, right?
Yeah, I mean, sort of everyday functional objects. They're familiar from archaeology. Whether it's a clay pot, we still eat from and drink from ceramic objects, and
that feel. And it's interesting. We're talking about that the feel, and in a very different context. Christian was talking about, if you look at a robotic arm, there isn't that feel. And from what I know about robotics, a lot of the problem is, if you get a robot arm to pick up a clay cup, for instance, it could like crush it, because it hasn't got that sense of touch of when to stop pressing. And that's fascinating, seeing how trying to adapt that to the medical profession, where you can't make those mistakes. It's got to be exactly precise.
And there's really very interesting kind of contrast, aren't there, between the certainty of producing routine sort of physical objects that we might use, but also the certainty that we gain from human action. And I suppose what's fascinating about the robotics solutions is that the notion of certainty they try to achieve is by reproducing the action largely in the same way on each and every occasion. Whereas what's delightful about human beings is they reproduce the action, but it's always tailored with regard to that particular moment or with that particular circumstance. And that gives its certainty, whether it's walking across a road or passing a tool to someone else. So it's almost a kind of contrasting notion of certainty that we associate often with standardized objects in some way. And I suspect that's part of the tension that arises from this very clever work on intelligent agents and robotics. It misconceives certainty within human action.
Yeah, I think essentially maybe that's our definition of certainty isn't quite right, because there's that idea of we talked before the session about being able to having to constantly monitor. So if you take the surgical procedure, I see that sort of quite analogous to a computer system, where to talk about jumping to another subject, but artificial intelligence. You can't say one computer has artificial intelligence, but maybe a network of computers working together at least shows the outward impression of intelligence. And for me, that's similar to a surgical team where they're all working synchronized to each other. And the difference is you kind of need somebody to be monitoring that and making sure it's all working precisely. And if you're just relying on a computer which apparently does everything precisely, you're still not looking at the kind of more holistic level of how is this all working together.
That's one way of thinking about it. But if you think of that, the kind of Thales argument, or even Humboldt argument about what's so wonderful about human beings is almost the infinite use of finite resources. That almost isn't what we have often with like technical solutions to these problems. So it's our ability to produce certainty out of contingency, which is, I think, so clever about human agents. But that's a very different notion of certainty that we might want to embody within an object or a machine.
Yeah, and I guess there's that the ability to adapt and to modify. So whether we're talking about repair or that's kind of interesting, like Katie's example, where the machine copying your drawing wasn't exactly precise, but also sometimes you like those, you kind of encourage those happy accidents, and there's that sort of various Japanese philosophies of you want a bit of imperfection. That's what brings the beauty out of it and the humanity.
Yeah, absolutely. Yeah, I think I was interested in the machine having a bit of a life of its own in that respect. So there was a mismatch between what was drawn on the Wacom and what the machine actually did. So yes, I think that happy accident is part of it, or wanting to be able to design that into a tool so that it can things turn out differently. I mean, I've done work with plotters where I've put my finger on the paper of the plotter to force different kinds of line on the surface of the paper, or where the surface of the paper is slightly bowed and you get too many lines, or and allowing the machine to make those mistakes, watching that, being with your machine, being with your tool to allow it to make mistakes is important, I think. Yeah,
I think that ties something that you said, Taz, about you don't really know until you've done it. Almost sometimes you don't even know what the problem is until you've been through it. It's kind of fascinating that our ability to kind of think on the job and adapt as we go along.
I think there's also sorry, go on.
Sorry, I was just saying, go ahead.
I think there can be a dialogue between the physical and the digital. I mean, in the case of drafting something on the computer, then sending it to the 3D printer, you get information when you're drafting, and you get another set of information when you have a physical object in front of you which is being printed, and that will take you back to the drafting, saying yes, this worked, that doesn't, and it's you're not outsourcing any of it. You have control over the whole thing, and it is actually teaching you things, that you perhaps didn't know, you didn't realize. It's to and fro, which eventually, ideally, allows you to hone the thing into loveliness.
Yeah, I loved also the fact you talked about the brick walls aren't normally intended to be transported 6 months. Is that sort of, there's a sort of a purpose, but sometimes, you get this kind of, challenges you have to overcome while you're going through the process.
Do you think...
Carry on, sorry.
I was just going to say, Taz, do you think then that sometimes your prototyped objects are becoming tools in and of themselves? What you kind of mean?
Absolutely, and it's all the failures too. You're learning all the time. Initially, I was learning the drafting package and spending an inordinate amount of time, making mistakes and, getting it wrong. And then you're learning, how to get the best print out of, the machine. And then you're, it's the back and forth, which is, it's immensely frustrating sometimes, but I think it stands you in good stead, potentially. I don't think it's for everyone because it takes an inordinate amount of time, really does. It's learning a new language. What I wasn't expecting was it actually teaches me things that I didn't know. It's a whole different way of thinking and a whole new range of possibilities. But like I say, it's not for everyone. The ideal would be to have someone that you look over their shoulder and you say, oh yeah, a little bit like that, a little bit like that, or yes, carry on, I'll come back in a fortnight and see how you're going. But I don't really have that relationship with anyone. I think the best thing about, for me, what I've experienced during this research period is that it's been really hard earned. I'm really frustrated. It's not my natural environment at all. I'm very hands-on. In fact, there's a question about what your favorite tool is. I had to think long and hard about that. And really, I suppose it's clay. It's a ball of clay or some material that you can model and manipulate because it has no form or shape of its own. And all of a sudden you're noodling around and then you have something that you really care about, and hang on to it. It's got possibilities. And that's in stark contrast to, all the really heavily sort of designed work that I do. And that's, I didn't show any of that side of it, but that's really who I am. But that, in a part that informs what you do because you have, a sense of form, hopefully, or, sensitivity to what you think works. But, ultimately it's all making it up. You kid yourself that you're doing something really interesting. You have to test it in the world, don't you?
I find that's really interesting because, like when you're fixing things, you don't really get the chance to iterate. It's a bit of a one shot, there's not an opportunity for prototyping or using those objects as tools except in a kind of longer practice of it. So it's really interesting to have that build up of information with the digital and with the clay.
But if you have the skills to make the thing in the first place, then you don't have to worry about ruining it because you can always
that's true. Well, I would argue that breaking it isn't necessarily ruining it, but that's a whole other conversation too.
Interesting. There's the Institute of Making. I don't know if anybody knows them up in London, and they've got this kind of process you're meant to, they invite anybody to come in and use their tools, and they have kind of basically have one of everything, pretty much digital or handheld. And people get terrified they've broken a tool, and this all breaks something. So that's how it's meant to break. That's the whole point. Because just don't break it twice. So once you've worked out what it's for, we might charge you for the second one. But I love that idea of come in, and it's kind of what we were talking about, teaching creativity in the first place. Tell people that just go ahead and break things. That's the only way. Obviously not if you're in a surgery situation, hopefully.
Surgery presumably is littered with awful occasions, and that's how those things have been developed over many years, and understandings of what illnesses are and how they need to be treated have been changed through that process. And then I guess we've got this kind of uncertainty of the way that the world is changing and the way the environment's changing, and those are the kind of disruptive influences for making new tools, I suppose, as well as the issue of how do you actually work with standardized models of things.
There was one question I wanted to pick up on, which was is actually asked in the original panel. I'm trying to find it, it's just disappeared. I think somebody might have answered it. Yeah, here we go. So Adrian's just booked in to answer. So Joe Garner asked, kind of off the back of Alice Naylor's presentation, but then kind of as a general question to everybody. I'll just read this out because it's slightly long, but I thought it was a good point. I'm really interested to see so much about digital technologies as tools, especially biohybrid tools as a way of alleviating environmental stress. And then in drawing a contrast between this and the Kenwood chef, I wondered if new tools, digital tools, biohybrid tools are less gendered. And if so, are you seeing evidence of this within design, production and implementation processes? Which I thought was quite an interesting point. It's kind of, we talked about the emancipation of tools, but it's also, we touched on the first panel, that there is in some instances a very masculine tools, whether it's an axe or if it's something, a knife that a chef uses, it's got quite a masculine connotation to it. And the fact that digital tools are much more freeing in that respect. I don't know if anybody's got any examples of that.
I think with the knife is a really interesting one because people do it's back to fetishization of objects, which is a kind of collecting and gathering together like the sort of tools in the tool shed. But certainly with digital, just the speakers today and the kind of questions we've had, it seems that digital tools just aren't gendered in the same way. And when I did my BA, and it was the very early days of 3D printing, there just wasn't any sense at all that it was a man's world. We had quite an even mix on my product design degree of men and women, and that there wasn't the sense in the same way in a workshop with routers and jigs and saws and things like that, which was always run by men. The metal workshop, the wood workshop, all the technicians were men. In the digital workshops that were emerging, that it was much more even-handed in terms of the gender balance.
Yeah, fascinating. There's a great question by Jem Ryan, but it's quite long for me to read out. So I might encourage people to look at that and maybe answer online because it's great, but it's quite long and it's very good. But the other thing I wanted to say, which Tas touched on, was just as a kind of an after sort of follow up on all this, we'd like to ask all attendees as well as panelists what their favourite tool is, which sounds quite a mundane question, but it's quite interesting to sort of hear people's reasonings, and quite often it's not what you think. And we spoke to, actually I've got an example of Gareth from the first example. We did this book on tools, and it was mainly about for Hole and Corners magazine I used to do. So it's mainly like beautiful axes made by the axe maker himself, and it's all very worthy. And you got to Gareth, and his was a power drill. He said, I might use all these amazing chisels, but at the end of the day, I always reach for a power drill. It's the thing I need, like domestic or professional. I just love that fact. Was like, it's very kind of takes some of the pretension out of it when you kind of realise the tools you actually need day-to-day life.
It's very versatile tool though. I've always got one with me.
Everyone should pull one out.
I rather boringly, I would actually say it is a knife, because you're not just cutting things with it. I mean, if you need it, the tip of a knife can be the best kind of screwdriver you can possibly have, and then prizing something, you're scraping something off the work surface, so that there isn't anything particularly that my own particular knife, which wasn't very expensive. And in fact, the knives that I use when I'm cooking are I don't have anything particularly expensive, so it's the sheer variety of them that is definitely it's one that gives me the feeling when I think about the tool. That's what it gives me. Yeah, that whole.
Yeah. Excellent. There was a question from Wong Jin Ho, I think I said that right, which I think is for Christian. I think you've probably answered this, Christian, but I'll just reiterate it. So would you say the issue with the machine in terms of robotic replacement of a scrub nurse is the lack of bespoke action? So the left-handed surgeon would prefer to work in a mirrored situation, use different tools, for example.
At the moment, the problem is that issue that we raised earlier about the different quality of certainty between a machine and a human being. That in a sense, our certainty in human action is our ongoingly accomplished certainty, isn't it? Whereas for a machine, it's its ability to produce a routine and recurrent set of actions in many cases. Could I just cheat though and go back to the earlier question?
Absolutely.
My favourite tool is the video camera. because for the first time in human history, we have a cheap and reliable technology where we can capture at least versions of human conduct and subject it to repeated scrutiny, which hitherto was historically never available. So instead of asking people why they do things, we can start to study how they do those things in situ. So I'm going to go for a digital technology for my.
That's good, yeah. But also, actually, I think, you know, if it's a, you know, an oral passing down of, you know, how things are made, people don't remember perfectly. You know, there isn't certainty in remembrance, and the way you think you do something is probably not the way it's observed. So, you know, it's fascinating to see it from another perspective as well.
But it's almost akin to the microscope in biology, that it opens up a world of richness and agency that we had no sense of until the last 30, 40 years.
Fantastic. Great. I think we're actually going to try and wrap it. Actually, you know, I'm going to go, there's one more question that Rosendi Glabo asked, which is quite good. And we kind of said this at the beginning, it's like, why is this panel called certainty? Which is true. But it says, but they go on to say that because tool use can change according to the context. So Bridget and Jason mentioned openness and appropriation of affordances. It's the difference between the tool and the machine, which I think is a really interesting point, because, you know, there's a lot of subtleties you can't sort of fit into a heading, but it's almost like the joy of uncertainty rather than certainty as the question, or how we embrace uncertainty and work with it, I suppose.
I was sorry, Jason.
Please.
No, you've got something much more.
No, I was going to make about crowbarring my work into this panel.
I was just thinking about kind of maybe it's about who's operating things, but it's not a very well thought out, you know, answer about what's powering something and what creates. I guess maybe the panel wasn't so much about certainty itself, but around ideas around certainty and the sort of difference between tools and machines being negligible, but maybe about power. And that none of which answers anything. So there you go. Carry on, Jason. Crowbar away.
Open-ended.
No, that is a good point about machines and tools, and I've really enjoyed the fact that we are sort of forcing them together in this situation, in this circumstance, seeing the synergies and understandings between them.
Great. Okay, well, I think I probably need to wrap it up now. It's been a fascinating afternoon. Thank you to everybody who's involved. Just to mention again, if anybody wants to kind of add in the comments anything about their favourite tool or anything new they've discovered about tools today, we'll kind of try and keep this live and kind of add a bit of extra feedback afterwards. But thank you everybody for taking part. It's an amazing afternoon.
I think Adrian and I are going to wrap up here with some comments. Are you there, Adrian?
I am indeed. Can you see me? I should have said that before I did my slide presentation. Yeah, but look, I mean, I think, can we blame the tools? And I think it's been a really fascinating afternoon that sort of says potentially that no, we can't blame the tools. I mean, we need them to inspire us and to create more haphazard moments, to be playful, to be social, to further craft and to further our knowledge of craft, and also to connect back to the origin of craft and the origin of tools and where the tools originate, which arguably is in the tacit and in the use of our hands and our environment. So I want to thank you all for a really, really exciting afternoon, which kind of makes me feel we're entering a new age, potentially a new age of tools. So without further ado, I shall go through the speakers. Obviously, a big thank you to Phil, Ayres, and Liz, Werner, Gareth Neal, Alice Naylor. I mean, I probably should, you know, in terms of the first panel discussion, and then obviously Christian Heath, Katie Bunnell, TASLIM Martin, and Bridget Harvey as well. And also a big thank you to Mark Hooper, who did a brilliant job there trying to capture as much of the thinking and the discussions and the questions and answers that were also coming our way from the panelists as well as from the participants. So I want to thank everyone who's attended. It's really fantastic to see everyone here. and such a great attendance. The other thing I should mention is I think Christiane is going to show one of her sketches. I think is that something, Christiane, you can do? I don't know.
And we'd really like to thank Christiane for the drawings that she's been undertaking during the show. That's been amazing. Thank you. And we look forward to seeing those. And there's another thing I need to ask you to do is to complete a short anonymous survey, which you can access after leaving the event. That would be great. And there's a newsletter that you can sign up to, there's a link after the event. And do talk about the symposium through the hashtag Blame the Tools. And Gabrielle has been amazing, who's done so much work on this. We have to finish by thanking her, I think, Adrian.
Yeah. Thank you, Gabrielle.
Thank you so much. It's been a pleasure. Thank you. I really enjoyed today.
Thank you. You've been amazing.
You all.
Thanks, Gabrielle.
It's been amazing. Lots of big hand claps.
And then, is there a virtual pub? There probably isn't.